Welcome to the AI Memory War. Today, we're diving deep into the technologies battling to give large language models the memory they desperately need. RAG versus long context. This battle is about more than just conversation length. It's about making AI trustworthy, informed, and truly useful in complex, real-world tasks. If you've used tools like ChatGPT, you've experienced the frustration. The AI seems brilliant one moment, and then suddenly forgets what you discussed just 10 minutes ago. Why? The core problem is that AIs don't have true, continuous memory. They only process information within a specific, limited operational space, and making that space larger is incredibly expensive. This limited operational space is what we call the context window. Think of it as the AI's short-term memory. The context window is the actual input and output text that the model can see and process at any given moment. It's measured in tokens, words, or pieces of words. Once the conversation exceeds this token limit, the AI starts dropping the oldest information. Visually, imagine the context window as your desk space. It can only hold so many documents. As new papers arrive, the old ones get shoved off the edge. This is what happens when the AI forgets. Why can't we just give the AI a bigger desk? Because the computational cost of increasing the context window is enormous. Processing information within this window increases exponentially as the window size grows, making ultra-long context prohibitively expensive to run. This is where the challenger steps in, Retrieval Augmented Generation, or RAG. If the context window is short-term memory, RAG is the infinite external library. RAG is a technique that gives the AI access to external, up-to-date knowledge. Instead of relying solely on its limited internal context, the AI first searches a massive database or library for relevant documents. Imagine the RAG database as a pristine, perfectly organized digital archive. When the AI needs an answer, it instantly finds the exact right book or file without having to remember the whole library at once. The process is simple. When you ask a question, RAG retrieves small, relevant chunks of information from the external database. These chunks are then inserted directly into the AI's small context window, allowing it to generate a grounded and accurate answer. So how do these two memory systems stack up? Let's compare the fundamental differences between the limited context window and the RAG approach. The context window provides short-term, immediate memory. It's fast because the information is already loaded, but it's fundamentally limited by size and becomes expensive quickly. RAG, on the other hand, provides long-term, external memory. It's scalable to massive amounts of data, but it requires an extra retrieval step, which can introduce a slight delay. The memory war isn't about one technique winning, it's about integration. What does the future of AI memory look like? The most effective AIs will combine both. They will use large, efficient context windows for immediate conversation and utilize RAG to access vast, external knowledge when needed, creating a seamless and powerful user experience. The race is on to make AI memory cheaper, faster, and more robust. Expect continuous innovation in both hardware efficiency for context and retrieval accuracy for RAG systems. Ultimately, RAG and long context are two sides of the same coin, each essential for unlocking the next generation of truly intelligent large language models. Remember, context is the immediate, expensive, short-term focus, while RAG is the scalable, cost-effective long-term library. If you enjoyed this deep dive into the AI memory war, subscribe to the channel for more breakdowns on cutting-edge technology.